This webinar will give you a taste of analyzing transcriptomics data in the limited time, and the same tool can be used for analyzing metabolomics data as well. We'll start at the home page for EcoPsych, the E. coli database, and go once again to the cellular overview, the metabolic network diagram. And we're now going to upload a transcriptomics data set from a file. This file contains a data set in a tab delimited format with one row per gene, and the first column consists of gene names and identifiers, and the remaining columns consist of measurements at 6 different time points. So we'll ask for columns 1 to 6. These are absolute transcript counts. And for now, we're going to visualize the imported data on this diagram, but I would encourage you to play around with several other tools, such as the omics dashboard. What the software is doing is to map transcript values to a color scale, and then to compute for each gene which reaction in the metabolic network it catalyzes. And it's then going to color that reaction with the associated color for that gene. And here's the result. Here's our color scale going from 0 to that number. We're actually going to collapse the color scale a bit so that we get more information shown in the diagram, because a few outliers were skewing the color scale. Now, in this particular data set, the E. coli cells are transitioning from growing in anaerobic conditions to growing aerobically. And so, for example, we can zoom in on any of these pathways. We can see that initially fermentation is highly expressed, but if we now turn on an animation, so this is our first time point, if we now turn on an animation, we can watch our 6 time points play by, and in fact we can stop at any of them and restart. We're now going to stop at the last time point, which is aerobic growth, where fermentation is downregulated. In contrast, the TCA cycle is upregulated, and we'll step forward one time step. At the beginning, now we're back to anaerobic growth, TCA cycle is downregulated. Another thing we can do is we can ask to see what reaction that is, and we can ask to see the omics data at that reaction. So there are 2 genes that catalyze that reaction, whose product catalyzes the reaction, and these are their expression profiles over each of those 6 time points. We have a variety of other gene expression analysis tools, such as the omics dashboard, enrichment analysis, etc. And all of these tools can also be used for metabolomics data. For metabolomics data, we can map the data once again to a color scale, but it becomes painted onto the metabolites rather than the reaction arrows.